Okay, the respiratory system is connected to the circulatory system. They work together. The respiratory system is all about how you get the oxygen from in the air and get it into your body. The circulatory system is about how once the oxygen is now in the body, how you get it out to the muscles. Together we call it the cardiorespiratory system. But we'll just look at it here in terms of the respiratory system. All right, you've got a number of different features. You've got air coming in through your nasal cavity, through your nose or your mouth, comes down through the trachea, comes into your lungs. You've got left and right lung. Now, once we get to a microscopic level here, at the end of these, what we call bronchioles, which are in your lungs, at the end of them, you've got these little air sacs. They're grape-like. They look like little grapes at the end of your bronchioles. And those are air sacs. And in there, the capillaries, which are the blood vessels, smother them. And the oxygen is diffused into the blood. And the carbon dioxide is put back into the lungs. All right, this is a system about getting that oxygen into the blood. We'll look a little bit more at that. Now, to enable air to come in, what you require is to either make your lungs big or make your lungs small. When you make your lungs small, the air pressure becomes more inside your lungs, and air will move from the high pressure in your lungs and it will move out to the lower pressure on the outside. When you expand your lungs out, breathing in, you lower the air pressure in your lungs, and air will move from the high pressure, which is now outside, into the lower pressure into your lungs. You do not suck air in and you do not breathe air and you do not push air out. You change the shape of your lungs to enable air to move in and move out. Want to breathe in? You open your lungs up and air will move in like a vacuum. You want to breathe out? You close your lungs down. And now air is at high pressure and it will go out just like a balloon. To enable that to happen, to make your lungs bigger and smaller, you've got a diaphragm, which is a muscle, and you've got intercostal muscles in the ribs. When you do aerobic and continuous training, you make those diaphragm and intercostal muscles better, more stronger, and that enables you to open your lungs out more and close your lungs down more as well. And that enables more air to move in and out. And we know that when we do exercise, we start breathing heavily. And if you can bring more air in, you're also bringing more oxygen in. And if you can get more air out every breath, you're also getting rid of more carbon dioxide. And that is an advantage. It's another physiological adaptation to doing exercise, having those diaphragm and intercostal muscles stronger to enable better breathing. Now, don't think that's relevant. These are those air sacs that I was talking about at a microscopic level. These capillaries are surrounding it. The capillaries come, these red blood cells travel through these capillaries. They're so small, the cells can only go through a single file. They come in without oxygen, deoxygenated blood. They've already been around the body and dropped off the oxygen. Now they're coming back. And they are diffusing the carbon dioxide, which is a waste product, back into the lungs or the alveoli. And meanwhile, the oxygen is coming into them. And it's happening through a process called diffusion. And by the time they leave that alveoli, they're now oxygenated. That is what is happening at a microscopic level. This is what is also happening at the muscles as well. Capillaries are surrounding those muscles, and it is releasing the oxygen into them to be used as fuel, and the carbon dioxide out. It's just working the opposite way. Capillaries are the key thing. Now, when you get fitter and better, do aerobic training, there is now more capillaries surrounding these alveoli. There is also more alveoli produced, and that increases the total lung capacity as well. The more alveoli you have, the more air you fit into your lungs. The more capillaries surrounding the alveoli, the more diffusion is happening. Both of them are functionally better. These are adaptations that are occurring at a physiological level. Now, there is one more thing I want to show you here. And that will be me finished talking after that. I've already discussed this a lot. We're interested in the long-term benefits of doing the long-term adaptations of doing aerobic training. Heart muscle increases in size and strength. That is particularly relevant. The left ventricle increases. The part of the heart that pumps blood out through the body increases, becomes stronger and becomes bigger. Cardiac output will thus increase. The amount of blood pumped around the heart each minute, it increases because of the stroke volume increase, the left ventricle increases. A lower resting heart rate, I discussed that. And you get a lower resting heart rate because the stroke volume is now increased. So more blood is coming out each beat. The cardiac output when you're resting remains the same. The same amount of blood, more blood is now coming out each beat of the heart, which means the resting heart rate can decrease. Increased number of capillaries and muscles, and an increased volume of blood and red blood cells. Respiratory system. Diaphragm and intercostal muscles increase. The increase in number of alveoli, the increase in vital capacity, amount of air that can be inhaled. We've discussed this. Increase of oxygen removal from carbon dioxide. So what you need to do is basically discuss these physiological changes that occur from doing aerobic or continuous training. All right, there's a couple other changes in terms of the muscles there as well. All right, but obviously we're mostly interested in the long-term benefits of aerobic. You need to be able to discuss the physiological changes that occur as a result of training, doing aerobic training there.